More vectors! Vectors everywhere! Okay, hey, just a reminder, guys, when we're talking about vectors, we have an initial point, and then we have a terminating point. Okay, that's initial, and then the one with the arrow at the end of the vector, that's your terminating point, terminating. I'm going to try to make sure I use the right vocabulary here, okay? So here we have two terminating points from two different vectors. Here we have an initial point and a terminating point, and here we have two initial points, okay? So if I started at this initial point and then followed the blue one, okay, I would get to the terminating point, and then this guy, this arrow is not saying I begin the next vector there. So if I go the other route, like let's say I use the purple one as my first one, and I'm traveling, I terminate right here. And then I guess this is gold or orange, yellow, I don't know what you call this. Yellow has an initial point there, and then it terminates right here. Okay, so this is what's happening. Vector E is being added to vector F. Okay, those are the two vectors that are being added. The resultant vector is vector D. Okay, that's how you read this illustration. It's kind of, I don't know, it's kind of weird, it's kind of difficult, but I guess if you find that point that has two initial points for two different vectors, that's where you're going to start. You're not going to start at the other ones because that's where you have two terminating points, and this is a terminating and an initial point. Okay, so this is what I got. All right, now let's look and see what we can, if any of these answers over here match that. And just a note, you can also put F first. It could be F then E equals D vector, and that's because addition is commutative. Okay, and so what do we see here? We see E plus F. Yeah, I see E plus F right here, so that's going to be our answer. Now, conversely, we had the subtraction one. The other one was addition. This one's subtraction. Now, for subtraction, we're going to think addition. Okay, we're going to think addition first. Look at what this says. Which equation correctly describes A in terms, vector A in terms of vector B and vector C? So that means A is going to be alone eventually. But let's do what we did before, okay? We have two initial points right there for two vectors, and it looks like I would want to go the way of the gold one first, because that leads me to another initial points for a different vector, and then that will take me to this guy. So if I went B vector plus A vector, that's going to get me C vector. Okay. Now this the directions say right here that we want to get the A alone. We want to get vector A alone. So that sounds kind of simple. We just need to subtract B vector from both sides, so we get A vector equals C vector minus B vector. And then I'm going to look to see if our answer is down here, and yeah, there it is. It is. So treat these like adding vectors here, okay? I called this the pathway in one of my other videos. This is the pathway method. It's not the parallelogram method, okay? We start with the first vector, and then we add the other vector, and then we get a resultant vector, which is the shortcut of the two. Okay, see, we took two vectors to get all the way to this point. This is the shortcut to that point. You start from the very first initial point, and then you just go straight to wherever those two vectors ended. Hope that helps.